this is the problem. Okay, are there any questions about this co-transduction and mapping by transduction?
No, not for me.
Okay, let me then close this. Let's see.
Dr. Banwit?
Yes.
So sorry, this is Saida. So I know you said there was an error on 3, but is it possible for us to discuss really quick the medium? Because I'm still struggling a little bit with that.
Oh, okay. So let me transduction problem. Okay. Okay, so P1 is grown on okay, let me see. Over here. It's grown on met plus H minus pure D strain and used to transduce a met minus H plus pure D minus strain, and pure D transductors were selected. What medium will you use to select for pure plus? So for pure plus, let me just, so you will use minimum medium glucose because we don't have any other sugars here. These are methionine, purine, acetate. And so you have pure, you are selecting for pure, they all should grow on that. And because it's methionine, so plus methionine plus acetate. No purine, you are selecting purine. Why do you want to be purine if all of them are going to be pure plus? Okay, and you have a question?
Oh, no, I was just saying, okay.
Oh, okay. I just want to make sure that you understand, because that's what I eliminated the other problem, which had a lot of this. And I know people are struggling with this kind of thing. And so what medium will you use to select the whether the pure plus transductants are met minus? Okay, remember that all of them are pure plus now, so you don't have to worry about pure plus, purine, because all of them are purine plus. So it's minimal medium, glucose, again, we have to give sugar. We are testing whether they are methionine plus, so we do not have methionine, but we add acetate. Okay, because some of them may be acetate minus, so you are testing whether they are met plus. So if they don't grow, then they are met minus. If they grow, they are met plus, right? There are only two possibilities here.
Right, okay, that makes sense. Thank you.
Yeah, so if they grow, they are met plus. If no growth, they are met minus. That's how you conclude whether they're met plus or minus. Now, if I ask this question, like, let's see, if the question was, let's do a different color. So what medium will you use to test whether the pure plus transductants are ACE plus? So can you tell me?
It would just be minimal medium with glucose.
Minimal medium, glucose, plus methionine, because this is testing for A's plus is independent of this one. So the previous ones, you have two classes. You have med plus and med minuses. Now you're only taking the pure pluses, okay? And then you're asking, are they med plus or med minus in this one? So this is the medium that you use. If they grow, they are med plus. If they do not grow, they are med minus. So now you have these two categories. Now you're asking a separate question, independent of the previous one. Are the pure plus transductants A's plus? You have to have, because the strain is met minus, you have to have methionine. You do not have to have purine. So if they grow, they are A's plus. If no growth, they are A's minus. Okay. So some of the pure pluses are going to be med plus, some are going to be med minus, some of the pure pluses are going to be A's plus, some are going to be A's. That's also where all this list of recombinants come from. You know, that's what this refers to. Okay, is that clear?
Yes, thank you.
The testing, okay, the testing done for this one, I'm not asking you if they are A's plus and med plus. That's a different question. I'm asking, are they A's plus or are they med plus? Asking for both at the same time becomes a more complex question. Okay, so any other questions about this transduction? It is overall is pretty straightforward. You just really need to pay attention to this class here, right? This is a critical class. That's why you really have to pay attention to this. Rare recombinants. Okay? Any other questions about this? Okay, so. Okay, let's see. And I had done this problem in the class last time. I had done this other one. This one is a probability. I think I had done this one, number 5. And I did number 6. And this one, I don't think I did this one. Is that correct? Yeah, no, I don't think. I think it was a few of you in class asked me. Okay, do you want me to go over this?
Yes, please.
Okay, so total progeny was determined by infecting what strain?
C600.
C600, that's good. Okay, so the lysate that you obtain is diluted 1 in 10 to the 8th, and you obtain 375 plaques. Okay, so now the number of recombinant was determined by co-infection of a strain. Which strain?
(594).
Yes, 594. That is the non-permissive or restrictive strain where only one class of recombinant grows. And which type of recombinant is that? What is the recombinant that grows in this strain?
Wild
type.
Wild type, exactly. Okay, let's go then into the next question. What is the number of recombinants? So you got on 594, where you determine recombinants, 235 plaques. When you dilute 10 to the 6, so let's see. Where's my, oops, where is the, let's see, where is the superscript? I don't see it. Oh, here. Okay, and remember that this represents only one of the recombinants. You have to account for the double mutant recombinant. So you have to multiply this number times 2. Oops. And that equals, let's see. $470, let's get rid of that. 470 times 10 to the 6. Okay, let's just copy and paste here. Okay, or the same as 4.7 equals 4.7 times 10 to the 8th. Okay, and let's see, what is the genotype of the recombinant? So what is the genotype of the recombinants?
Will it be the double mutant and the wild type?
Yes, very good. So it's the double mutant. So let me just, so I don't have to fumble with this stuff. So that and lambda W plus T plus. Oops. Two recombinants. Okay. I don't know. I thought I had asked what is the total progeny? Well, it's 3 point. Yeah, it's here from this number. Okay. So what is the percent recombination between these two? So recombination frequency equals recombinants. So divided by total progeny, which is equal to 375 times 10 to the 8th. Oops, 10. Why is this so big? Divided by, no, I'm sorry. This is, it's 4.7 times 10 to the 8th. Divided by the total progeny. Okay, so that equals two to 5, 3 times 10 to the minus 2, if I'm correct. Okay. And the percent recombination. Two, 5, 3. So that is the percent recombination. Is that what you got?
Yes.
Yes.
Okay. So that's very straightforward. Now what you have to pay attention is to the strains. That's critical. Okay. And this problem is to show integration of lambda. Well, that is, I have that in the slides. What phage protein catalyzes integration? What is the phage protein that catalyzes this? You should know that.
Is it INT?
Yeah, integrase. And what is a prophage? Again, you need to know this by this
Bacteria
time.
with the integrated phage sequence.
Yes, there's a phage. And what protein catalyzes excision? Again, you need to notice this is in the readings. That's why doing the reading is important, because I don't talk about everything. Okay. So you really need to figure that out. You need to do the reading. I'm not going to do the reading for you. It's not going to help you. If I do the reading for you, it's not going to help you in your.
Is it CI?
CI? No. C1 is no. C1 is not. Please don't tell me that, because I'm ready to cry if you tell me that. Okay. So are there any other questions about these bacteriophage lambda problems?
Professor, could you please go over number 5?
5. I did this in class last time.
Number 5?
Yes, this one.
Yes.
Bacteria at a concentration of 1.58 are infected with lambda at a concentration of 4.5 phage. How many infected bacteria are there? Well, the first thing you have to do is you have to calculate the MOI. MOI, oops, what is it? It's the underline. So, okay. So what is the MOI? Sayana, tell me. You ask me. Anybody? What is the MOI here?
Is it 3?
Bacteria, which is 3.
Yes, it's 3. It's phage over bacteria 4.5 divided by 1.5. You know, the exponents are the same. It's 3. It's phage over bacteria. There are more phage than bacteria. Okay? So the infected bacteria would be the what have done this problem? So the probability is probability of infection equals 1 minus P, oops, 0, which equals 1 minus E to the minus 3. And that equals 1 minus, okay, minus 3. Somebody has the number already.
Yeah, I do, Professor. I believe that one is going to be 1.425 times 10 to the 8th. I'm pretty sure.
Okay, wait a moment. What is e to the minus 3?
Oh, sorry. Here, I'll pull that up. I have it just written out.
Yeah, I had the problem and I.
It's,
It's
0.05. Oh, there you go.
0.05.
0.5? No, it's 49 something, right?
497. Yeah. Or 498, sorry.
49. Yeah, okay. And so this is 1 minus that. It's going to be 1 minus 97 equals 0.9503.
Yeah, I don't shake. There's one banana in the hospital.
0.903. So that means that 95% of the cells are going to be infected. So infected cells is going to be, we have this many cells, okay?
Or were you having them?
Will you please mute yourself, whoever is there with the stuff on, because it's very distracting. Okay, so this times, oh, oops, why is this getting me 16? 16 times 0.9503, which equals 1.4 something or the other. 1.5 times 0.9503 equals 14254. So that is times 10 to the 8th. Infected cells, bacteria per mil, okay, which is very close to this because the MOI is pretty high. So it's going to be very close to this initial number of cells. But what this shows is that not every cell, despite the MOI being high, not every cell is infected. Okay, how many phage are going to be released after 1 hour? So it's going to be this number. This number times 100. 116, 112 here, times 100. So it's going to be equal to 1.43 times 10 to the 10th. Phage per mil. That's the burst size. Okay. So first, for this kind of problem, you have to know what the MOI is, because you need that for calculating the probability of infections inside cell use probability. And then the probability of infection is given by this formula. And this tells you that 95% of the cells are going to be infected. So it's not 100%, it's 95. So it's going to be less than the initial number, but very close to it. This is very close. Okay, and how many phage are released? That's the burst size is 100 times the number of infected bacteria. Is that clear? Somebody asked me to do this problem and okay. Are there any other questions about this problem set? Are there?
Dr. Banya?
Yes.
I was actually wondering if we can do 4 if we have time, since we have a little time.